Okay, now we will move a little bit more to the southwest of Spain, 100 kilometers maybe away from Granada. We will get to Málaga, which is closer to the Mediterranean, or it's at the Mediterranean. Professor Enrique Alba is from the University of Málaga. He's also one of the most cited scientists, computer scientists in Spain. He's also involved in a huge number of projects on the national as well as the international level. He's also working quite a lot with industry and so on. His one of the fields he is working on, of course, is smart cities, and I'm very proud to be able to announce that Professor Alba will now give a talk about intelligent systems for smart cities. So thank you very much.
Thank you. Well, thank you. I would like to start by really thanking the organizers of this conference series. Thank you for having me here. Thank you for being here to hear my presentation. We will take some time to analyze this amazing combination of two fields, the field of intelligent systems and the field of smart cities. So the point here in this presentation is that we want to have these two big fields, intelligent systems and smart cities, together so that we can transform our society. So we have something like a romantic view of research in which we are having nice ideas and then we pursue these ideas to the end until these ideas are having a benefit and a good impact in our lives and the lives of our relatives and neighborhood. So what we want to do here is to combine intelligent systems, there are many, this is a huge domain, with smart cities. We want to transform the cities. As you probably know, cities are receiving the largest amount of people in this century. So immigration, even if you are thinking that immigration is happening between different countries, immigration is actually happening for the countryside to the city itself. So this is provoking a lot of problems in general all over the world in every single continent. So the point here is that people are arriving to cities in a faster pace than the city can accommodate all these persons coming there to live. So people living in cities are requesting every single day more services and better quality services than the city itself can deliver. So we have here a problem, and if we are not using something like intelligent systems and technology, it will be extremely difficult to match the growing pace of cities and humankind with respect to the services and the infrastructures we do have right now. So by using intelligent systems, we expect to go from the old cities idea, all energy consumption and production, and the kind of transformation and transportation we used to have, to the new, marvelous heaven cities in which we are here in the middle trying to fight the old habits and old problems existing in our cities to put cities in, let's say, in the 21st century. Well, everything will happen probably by relying on many things, relying also on data, of course. You all know that data is very important. My friend Paco did a marvelous presentation on the importance of data and how transforming and pre-processing data is making better models. But now let me make a little bit of stress in the intelligence we have in the dynamic part, in the active part of everything, which is the algorithm. So the algorithm is dealing with the data, and the algorithm is giving life to things, because data is there in the hard drive and it's not doing anything. We can look at the data, we can make lots of things with it. It's a little bit static guy there. So we want something that is dynamic, and the algorithm is transforming things and giving us a solution to problems. So from the side of algorithms, we will find many interesting things. And the point is that most people right now, all over the world, is using old algorithms. So these old algorithms sometimes are like a blind person trying to find the way till an optimum of the very complex function or a very complex system in which maybe we don't have even an analytical representation of this system or function, but still we want the optimal solution. And traditional algorithms, the ones we are right now teaching in many faculties and schools all over the world, are very old-fashioned. So we need to transform and change this kind of teaching and this kind of research and advance a little bit, because we need to move out of these, let's say, too much classic techniques and at least combine these techniques to new ones, because we are using something like brute force to solve problems, and the problems you can find in cities cannot be solved by using brute force. So we need something that is actually intelligent. So where are we finding this kind of intelligent systems? Well, we will try, we will find the solutions for the problems we have with these new intelligent techniques. Where are they coming from? Well, optimization is one domain where these techniques can come from, because optimization is everything. You might be thinking that you are not using optimization in your daily life or in your research, that you are not interested in it, you don't have time to look for this, but if you think twice, you will find optimization happening when you are filling your fridge, when you are going to the supermarket and picking only the products you need with the healthy conditions for you at the smallest cost, and then you want to put all of them in your car and they don't fit, and you need to think in the constraints of your car, you need to think on the constraints of your fridge, and then you take all of these to home and then organize this inside the fridge. And this is optimization. You are making lots of optimizations with many objectives and under many constraints. If you think in a fire, right now we are seeing many fires as every summer we see in the world. Fighting a fire is nothing else than reducing the area that is burned right now, is burning maybe to zero. We want to optimize, minimize this area to zero. So fighting fires is optimization. Filling your fridge is optimization. And learning is optimization. When you want to reduce your error to zero, you want to minimize your error. So from this field, you can find many ideas and many algorithms already standing out there for you to use, or you can develop new algorithms for your new research. And for smart cities, we need this kind of algorithms. Of course, learning, optimization, and search itself are very, very well linked together. They are something like different parts of an elephant. If you touch different parts of the elephant, you might think that it's a different animal, but at the end it's one single animal, which is the elephant itself. So optimization, learning, and search, they are all together playing a game for helping us in solving difficult problems, especially in cities. Well, let me just give you a hint on bio-inspired algorithms, because I've been working there for a long time. And we can develop solutions inspired in nature. You know that nature has been solving problems much better than us, humankind, and much before us in history. So we can rely on nature to inspire ourselves, to make new computer programs, and to create new techniques that will solve the complex problems we have in smart cities. So it's a good way of thinking to rely on nature, to get some procedures there, put them in the computer, and get a solution where other people and other lines of research are not successful in finding solutions for the problems. And now we arrive maybe to the cities, because we have been talking about optimization, learning, and intelligent systems in general. But what about the city? What is a city? Where is the city coming from? Well, of course, I'm not making a long speech here about this, but it's interesting to see that most of the concepts we already are having right now in cities are coming from a long time ago. where human beings were moving along the planet, taking everything on their shoulders and moving from place to place, and the concept of home, the concept of transport was different, and the concept of food or family was different. From this moment on, when people started to stay in different parts of the planet, many concepts arrived to us, and many concepts are still here. The very concept of future is coming from cities, because when you stay by a river, you will pass there the winter, and in winter you don't have any food. So you need to foresee and plan for the future. And then future started to come to us because of cities. And cities were evolving, having streets, having transport, having defenses, having an economy, having energy, making people and goods moving from one part to the city to another. And then you saw the rise of different cities, and then people were moving between cities with long distance transport, and then economies and interspecies matching were expecting there with animals and with other things. So many of the concepts we have are coming from old cities. Our cities today are having many of these concepts. They are not so much evolved, although we want much better cities than in the past. And these are the new cities we want right now. These cities are having technology all over the place, and you need to be careful in distinguishing between enabling technologies and intelligent technologies, because enabling technologies are very important, but they are just enabling the connection and the communication and the rest of things we want. So communications are doing a good deal of good things for us, but communications are not intelligent systems by themselves, because they are just putting things from one side of the city to another side of the city. They are very important, they are necessary, so we need more advanced cyber-physical systems, and in order to make these cyber-physical systems to work, we need intelligent systems making things happen in there. So what we have in a modern city is a set of sensors and actuators. People only usually think on sensors, but you must think also on actuators, because you want to make something to happen in the other part of the city. You don't only want to receive data, you also want to have an impact in the city. So you want to turn on a light in other part of the city, not only to know whether there are some persons around this lamppost in the city. You want to act. So we have sensors, we have also actuators. We have communications taking data along the city, we have data centers analyzing and receiving all this data, and then we have the services. And these are the services we want. We want to help handicapped people. We want to help taxi drivers. We want to help your mom, your father, your son, your daughter, your neighbor. You want to impact, to have benefits in your schools and in your hospitals and in your streets. So these are the services we want, and these are the ingredients we have. So intelligent systems will come here and then make the transformation of the city to have these new services, because we want that for our cities. And every city is in a different position right now to evolve towards smarter cities in the future. So every city is interested in using smart and intelligent systems in a different way. But most cities today want to go for smarter in the future. Let me share with you the 2 points of view I have for working in smart cities. I have 2 views of them. It's about thinking big or thinking small. Thinking big means that you address the problems of the city and the services of the city in thinking all of it. You think in the city as an object, as an artifact, and you want to impact in it. So you want to collaborate to people in the whole, the Department of Mobility of your city, or the Department of Energy, controlling energy in the city, and then you make an application and a service for them. So you go to the mayor of the city and talk to her, talk to him about how to improve the city itself with a nice application you are making. This is thinking big. You are going top down. But there's another way of impacting in cities, which is going bottom up. It's thinking small. We all have in our pockets something that is similar to a smartphone, right? Or smart wrist or whatever. We have many gadgets with us, but the phone is pervasive. So we can make applications for the phone phones, and then these applications, small applications running on your phones, can get together and can work together to make better things on the city. So this is a little bit going on the contrary, bottom up. So by impacting in the city in these two ways, you can have lots of new and very interesting things for citizens in today's world. Okay, these are our two views, but you know, most people in keynotes are making something like blah, 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 not our cases, because we are good scientists. So what we need is a little bit to quantify and to define. If you don't define what you are doing, you can hardly transmit this information or evolve yourself in doing things. So one intriguing point here is what is a small city, of course. What is a smart city? This is difficult. There are many standard organizations trying to define what is a smart city, and it defines your goal. So I'm just picking here one of them, I think most for today definition of smart cities, which is a long one. But I just put in bold some things like real-time, sustainability of the city, holistic point of view. That's very important. Lots of people have been dealing with intelligent transport, but the city itself and the smart city concept needs from you that you take care not only on the transport, also on the economy, also on the energy, also on the health of people in the city. So the holistic point of view is very important when you go into cities. So this is a very interesting concept. In addition to real-time sustainability, data, open data is very important because most cities in the world are sharing their data in web pages, but this is not working quite well because the format is very important. People are not taking care of the format. And then not to mention that when you see lots of announcements that my city is having lots of data available for you, if you make a couple of clicks, you will find out that they are not having this data at all. So lots of cities in the world are offering you 2 pages of data, and then after these 2 pages clicks, you will not arrive to a single file of data, which is deceiving, and this is happening. So still we are far on what we need. But open data is very important also for smart cities, as many other things. And in this definition, people thought about intelligent systems, because intelligent systems are the key point transforming the city itself, being active. Of course, there are many cities in the world, and every city is performing a kind of analysis how intelligent we are, and they are asking the developers and the managers of the city and the citizens, and well, this is just an example of a city in Spain saying that, well, we think we are intelligent, we need to evolve. That's true because most cities are not having very important intelligent systems driving them. There's another thing here in smart city. It's a very complex domain. We have players. We can recognize their companies because they are running sometimes their services in the cities. So sometimes you want to put something to work and you need to deal with a company because it's the company who is offering the service to the citizens, to the final users. We have the university itself as the place where knowledge is being built. And we have also citizens. Citizens are the true target of smart cities. We all want citizens to be happier. This is the final goal, which is a very romantic and nice one. We want people to be happier, and we have the tools to make people happier. And well, there's something here which is black, which is the gap I'm using for the last player we do have there in the cities. And we cannot hear the music, but it's Star Wars Imperial March. Dum, dum, da, dum, dum, da, dum, dum, da, dum. Yeah, managers. You can spend a great deal of your time dealing with managers in cities with no results at all, because we're dealing with science, and managers are dealing with politics, and we don't match that much. So, well, it's a complex world. You may have the best service and best intelligence system in the world, but it will never go through and will be offered to citizens because you never press the correct key there. So, it's a complex player, but everyone is complex in its own, right? So we need to know and then deal with them. Well, when you see the city with this point of view, we want smarter services there. The city is complex. We have lots of places there in the city. We have energy, we have gas, we have new types of energy like wind energy and solar energy. We have water, because energy and water, they are very important for cities. They are having most of the budget of the city itself, so they will not pay for your nice project in the university, because they need to pay for the lights in the streets, and that's all, period. So you need to think about the energy and the water there. You have lots of things like transport and education and health and many other things, workplaces and traveling and the internet services and the communication services, and all your sensors are getting old in the city, and after 5 years they are not working, and you spend lots of millions in setting these sensors in the city, and you need to decide whether to put more millions on these sensors not working anymore, and there is a complex ecosystem of solutions here, hardware and software. So here we are with some intelligent algorithms trying to make the city smarter. Well, if we are all collaborating, it's much better for this, because, you know, when something is happening for the first time in the world, like smart cities and intelligent systems, people are a little bit lost, and they are trying to remake again and again and again the same concepts and the same taxonomies and the same classifications. And my new idea is this way. Well, you might know that in Europe we already have a classification of smart cities applications, so we have 6 axes, and that is much better if you fit one of these axes with your new intelligent system, because it will go through all the pipe of process till citizens faster. So we have environment, living, mobility, governance, economy, and people. These have been already adopted in Europe, and many other people are still looking for this. Good that we have these, and we can organize around these things. So for many years now, Europe has been doing things in smart cities, and there are lots of people and companies doing things, and they get together around these axes. So you can meet people and internet places that are making things similar to yours. So you can get in contact to colleagues in Europe easily. Well, blah, blah, blah. Let's go to real services, and let's go for things you can grasp, because this is too abstract, maybe, and I'm spending too much time. So let's go for actual services, and let's start by transport, because transport is very important, not only for persons, also for goods. So this is an example of different types of transport we are putting into work in different cities of the world. Where we are living in Málaga, so we are making lots of things with the Málaga councillors and Málaga people departments there. This is a kind of system in which we are tracking what is happening in the roads of the city, and then we are helping people to know better roads automatically. So we get the data of the people. We can have the data in many ways, through the smartphones, through spots in the city with Wi-Fi. Of course, it's a free Wi-Fi. It's ad hoc communication. So you pass by, you leave your data anonymously, of course. Security and safety and everything about anonymity is very important. And then you get new roads, or you get new, let's say, instructions on how to move depending on your destinations. These are some of the system-based, well, because you are having here some numerical data showing that you can reduce the traveling time in the city, you can reduce the pollution in the city, you can reduce the CO2 emissions, the footprint there, the carbon footprint there. And this is very important. It's not only on taking people in the shorter time, it's taking people, reducing also the energy consumption, reducing the pollution, reducing their times, all of it at the same time. This is a holistic point of view. And we have many approaches to this. Yellow Swarm is a new system we have been doing based on panels. So you can sit panels in the city and make some advices to drivers. Even if they are not taking your advices, we can show that the city will be better, even if many drivers are not paying attention to these suggestions. So there are many ways of impacting in people. Of course, we are going to other cities. We are making complex simulations, because there's no equation for the time or for the pollution in a city. So you need to go for technology. We need high-performance computing, lots of computers to simulate the city itself. Every single car is there into the computer. and then we can have also the real maps with the real traffic lights and the real traffic directions and traffic rules of the city. This is very important to have real data. So then we go to the scientific part, and then we show that we need a minimum number of vehicles using our system to work, and then we can show that 300 vehicles in some parts of the city is enough for having a big impact in the city, which is good, because otherwise you don't know, and then your system probably will need, imagine a system needing 1 million cars paying attention to some app in your phone. It will never happen. So we need to research on which is the minimum number of cars used in your system to have an impact in the city, in the pollution and in the time and in the well-being of people. Things like so has been done there. We have, of course, lots of results. I'm presenting here some of the case studies we did in Málaga. Some others will not on our own. It's existing in the world. And you can see that there are also lots of studies similar to the ones we can find usually in these conferences in the realm of algorithms research for learning and for optimization. We go, of course, for different cities in the world, because there are many questions like whether cities in Europe are the ones we are targeting and not cities, new cities like the ones in America, or cities like the ones in Australia, or cities in Japan or China. Are these cities also benefiting from our services and new intelligent systems? This is tough, of course, because you need to master all the maps of these parts, all the simulations with the real data of these cities, and then put the algorithms to work. So it's a huge amount of work just to show you a graph or one picture in 1 second here. So we did it for Berlin, we did it for Paris, we did it for Stockholm, in which we have this kind of cupped cities in which the streets are not really linear. We went also to America, States, Canada, Argentina, Mexico, and also we went to Japan and the UK, because you know that these guys are driving on the other side, which shouldn't be a problem because it's something like a mirror, but it's not that easy, and these authorities, when they are going to use any transport advice, they want this advice to be running on their rules. So they are driving on the other side, so they want the system to work and to be shown to work on the other side. So Japan, UK, and some other countries are driving on the other side compared to us, and then they need to know that this is working. So, well, this is just to show you, maybe you think that the numbers are small, but in a city you might know that 5% is a magic number. So if you can save time or you can save pollution, you can reduce pollution by 5%, then you are making a big benefit and big impact in the city itself. So 5% is not a low amount of percentage. It's a big amount of percentage because it translates to a big amount of power or air or energy in the city when you apply it to the city itself. We have many other things here happening in transport. This is a system regulating the traffic lights, sorry for the Spanish, because it's an actual application we are using in Spain and other Spanish-speaking language countries. You might know maybe that Spanish is the second naturally spoken language in the world, second one, naturally spoken. So good thing to have some Spaniard over there. So this is being used in some cities for controlling the traffic lights, and it's based on the flux of birds. And this is the actual application where you have, this is Málaga, this is a real map of Málaga. These are the places for the traffic lights, which is not easy to have, because mayors and the developers and the managers of the city, they don't want to share with you this kind of information, because it could be taken in the wrong way. So the latitude and the longitude of the traffic light, just this is very difficult to have, not to mention the program that the traffic lights is using along the day. And then we are running all these with intelligent algorithms with an interface for the user, and then this is running and finding different points, and every point is a set of configurations for the traffic lights of your city, so that your time in red in all the traffic lights will be the perfect one and the optimal one for the city itself, across the whole city, across the whole year, across all the districts of the city. So this is difficult because you have here the different type of days and the different zones of the city, just in case you want to optimize only one district in the city and not the whole city, which is much more difficult. And then you have the goals there to run, and then you have your click there, and you just use your finger, click. and then the city is being optimized. Then, in this sense, they are getting the programs for the traffic lights of the city, and we offer different colors. So red means this traffic light is really badly defined or organized. You need to go there and change it. The green one is not bad. You could leave it as it is. And the yellow one is, okay, if you have the time and the effort and the money, you can go there and change these traffic lights. Okay? So this is a really interesting way of changing our cities with the use of intelligent system. In this case, we are using PSO, which is a well-known algorithm based in nature. There are many others. We are using many others, and multi-objective, high-performance computing, and human interfaces and real data. All of it in this same application. There are many others, like remember the Think Small? This is an app for your mobile phone based on ants, in which you can have the best route for you to go to a destination in the city according to time, according to distance, according to pollution, and according to all of them together. So what is doing Google? Because you might be thinking, Google is doing that things. If I'm asking for a road from A to B, I will have my road. Yeah, you all will have the same road. Good for you, Google. You are provoking traffic jams in our cities. Well done. So the point is that every person should have maybe a slightly different road to go from point A to point B, so that we will avoid this kind of jams by construction. And if you are going from this point and this point, and two of you are going, maybe one street will be a little bit different for you. And then you will diversify the traffic in the city and not provoke any jams. This can be used in many other ways. This is a real application. Also, the sample again is in Málaga. This is a map of Málaga. You might be knowing Málaga right now because of these maps. And there are many others. We are in the media. This domain means you need to go to the media. Sorry for that. We need to use our time to go to the TVs and the newspapers and tell them, yeah, we are good. We are making ants for the city. So maybe you don't like it, but if you want to have an impact in actual cities, you need to devote part of your time to make these kind of things. There are many other things that you can make in transport, just a few hints. These are two apps. This app is to help the city itself to know the streets. So every city is having usually a floating car, at least a floating car, which is a car in which a couple of persons are moving around the city and having the times and the stops and the problems of the city every day. And this app is supposed to do this kind of job by itself. So you can save at least the work time and the payment and the salary for one person. This person can be put to make another interesting thing for the city. So this is one interesting application. This is another one which is very interesting in Spain, in which you can go from point A to point B in avoiding the sun in your face. We don't want right now in September, in August, to have the sun in our faces. Maybe here in Leipzig you want it. Maybe in some other parts of the planet people like it. It's easy to reverse the conditions and the functions there, and then you will go the road through the shades or through the sun. This is just a small thing to let you know that you can have a true impact in the life of people by small things like an app that can be done by two persons in your lab. So this is the bottom-up way of thinking, and you will have algorithms running on the edge, which is the next idea after big data. You cannot have all the data of a city of the world in one single big center. This will not happen. You go to the edge and you run algorithms on the mobile phones and on the routers you have there connecting your mobile phone to the network itself. Computing on the edge is a way of naturally distributing computing to the final users and then helping them on site. So this means we have to research on how to run machine learning on a mobile phone. Is it okay? What about the battery? What about the reduced memory there? There are many other concepts and constraints happening when you don't have a normal computer on your hands. Well, just a hint. There are many other things you can make in transport, like connecting cars between them with no payment to any provider. So you are using adopt modes in your mobile phones. This is people on my lab making connections and services to avoid traffic jams, to avoid accidents in the joints of the city. There are many applications of these kind of VANETs, which are vehicular adult networks. We are having some research in the world and also in our group on parking places, finding parking spots in the city, predicting the parking slots in subterranean places. This is very useful for people. This afternoon I'm going to the opera. Should I have a parking place for me? Please tell me. And then the application will tell you, yes, you will have 50 parking slots there, go there. So this kind of machine learning for prediction is very interesting. It's already running. We have prototypes and we had a few awards for this kind of applications. Well, transport is not everything. It's very important, but it's not everything. There are many other things in intelligent systems you can use for smart cities. Building new buildings. Yes, you can build a building using intelligent systems automatically. So you can have tools for helping architects to define new buildings, the aesthetic part, but also the energy part, and the restriction and constraint that all engineers going to the building need to meet. So this is just an example of the language you are managing in your algorithm. This is the building expressed in the language that the computer is using, and at the end this is expression, because you know that architects are running out of original ideas. They are copying each other, they have a limited mind for this creativity, so they need some kind of tools also for helping them in this. Tourism is very important. Spain is usually the second largest country in terms of received foreigners for tourism. So tourism is very important. You can impact in tourism in going to the databases of the hotels, or you can make apps for the visitors coming to your harbor or coming to your train station, and then tell them how to visit the museums in your city in the shortest time. So today I have only one day, which is the route I should go for visiting the higher number of museums in my city. Málaga is having 30 museums, so I want to see at least 5 museums. Can I do it? Yeah. These are the queues in the museums. This is the time for the museums. These are your tickets. That's it. You just arrived, you have your day planned. There are many ways of making this kind of intelligence system for tourism. Of course, surveillance, helping police, helping firefighting in the city with drones, without drones, to fight fires or to avoid restrictions there on the roads, because you are not using any crane, you are using drones. There are many applications there. What about energy? This is very important also in cities. So let's go for energy production. Energy production can be done in many ways. This is an example of wind production. This is, you know, intelligent systems can be used to design the wind farm so that the maximum amount of energy is produced along the year. This is a real example we went to with Argentina, in the Patagonia, in the south of America. This is about production, and there's a place there for optimization and machine learning. There are many other ways in which you can impact in energy, like reducing your consumption at home. So every time that you plug something in your wall at home, the line at home is receiving small changes in the signal. So you don't need to change your home, you just need to track these small changes that are being produced in the signal at home as you are plugging on your computer or your TV or your micro oven. And then you can detect what is being plugged, and then you can define a better plan for the family, and then you can reduce the bill of the family and energy. In some countries, your neighborhood can be planned together to reduce the peak amount of energy needed for running a whole day or a whole month, and then you will have all of you in your neighborhood a small bill. So this is very interesting, happening right now in other countries in Europe, like Norway and Finland, and they are getting together people in the neighborhoods to reduce their bill, which is very interesting. You can plan also the automatic start of your washing machine or dishwashing machine, whatever. There are many other applications like lighting. I told you that most of the budget is going for lights. This is like so because we are not having LED lights today in most of the cities. So we need a reduction there. Things like having an intelligent system analyzing how many people are around the light and increasing the intensity of the light. And when nobody's there, reduce the intensity of the light by itself. This is a very interesting application. Of course, there are legal implications because you cannot leave this part of the city in complete darkness, because then you are reinforcing crime, and that this is not good for most cities in the world. So people want to meet this kind of constraints, and this is a very important application. Water is the other one. So you don't need to water all your gardens every single day. You can have simple sensors there, and you can have a main window in the premises of the hall, and then you can track what is happening in the gardens and send the gardeners only to the place where they are needed today, and then save money, save time, and use this human task force for other things needed in the city. So you are optimizing the city itself when you are optimizing just one part of it. Many other things like waste management and circular economy. Circular economy means that you take your waste, you make something out of this waste, and then you put goods to the market again. An example is taking plastic out of the containers, and then with this plastic you build something new, like hangers for your clothes, and then you sell these hangers in the market. So you can make this kind of circular economy. This is very important today. And then you can use smart and intelligent algorithms there for waste management. We are running 3 projects out of this idea. Of course, big data is very important. I hope you appreciate my tricky strain there. I'm more on the Star Wars, I must say, but Star Trek is not that bad. So big data is over there, and he's in most places. We need to deal with lots of data in real time, with high-performance computing technology, and we are making lots of these things together at the same time. So this is something we need to take into account. Open data is also very important. If cities are not engaging open data, then we are all going behind schedules, because we want more data. We need data to make cities better. And hopefully, who knows, maybe in a very distant future, politicians will take decisions based on data. Who knows? It's good to have some dream. Well, there are many ways in going for cities and data and intelligence system. I just want to finish here in telling you that cities are something new. Smart cities are a new concept. You need to keep in mind that it's about being holistic. You cannot go just from one part of the city, because everything is interlinked. So you need to take care of all the parts of the city involved in what you're doing. You will see cities in a very different manner now, because you will think in a city as an object, as a place where you can have an impact in your research. Go there. You can translate your ideas. Your work alone in your office can be of actual importance for people, and you can do it if you go into this domain. It's not easy, because you need lots of things. You need the technology, the knowledge, the machines, the data, and the involvement of companies, and also the involvement of the city itself. But it's very interesting, and it's a new concept that we all will be dealing with in the future. So this is where we are. We are in the middle trying to make this change. I encourage you to contact us in Málaga whenever you want, to visit us, to drop an email, and to ask for data or for algorithms. If we have it, of course, we will share with you, and we want to collaborate, because research today is done in a collaborative manner, of course. And while there are many other things to be said about smart cities and intelligent systems, but I'm stopping here. Thank you.
Thank you, Professor Alba, for this very, very interesting talk. There's a little bit of time left for questions. Okay.
Thank you. It was a very interesting perspective and a holistic view of the smart city idea. You presented a lot of concepts on aggregating data on cities and its citizens. You mentioned mobility of the citizens. You mentioned monitoring home consumption of resources. You mentioned managing waste. So this is quite a lot of data about the citizens themselves. And I would like to hear hear a few words of your comment and your thoughts about privacy and security of this data regarding the citizens, the individuals who are in it, especially in the context of the concept of open data. So what are your thoughts on this? Thank you.
Thank you for your question. It's a very important issue. Of course, I just mentioned it a couple of times because it could be a complete keynote about it. Anonymity and the rights of people are of highest importance for everyone. We have a new law in Europe for this, thanks God, and then we need to meet this law. This means that most data, if not all of it, should be for everyone completely anonymous, so every researcher dealing with data should not know about the telephone numbers or the ID number or the habits you are having at home, of course, and this is very of the utmost importance. And nowadays, cities are the ones taking care of this when they are offering the data, the open data, in theory. Because sometimes I've been meeting many cities and they have very nice ideas, but they want things like your bag with your waste at home to be used, to have on it something like a barcode there. And then every time you're having your back to the waste, then they will analyze what is there, which is a very bad idea because they can trace completely your life at home, and this should be completely removed and avoided. So it's difficult because not everyone is having a good knowledge about anonymity. So this is being reinforced by anyone dealing in this domain. You can be sure that everyone who is making a serious work in smart cities knows about privacy and safety of people. There's another way of thinking here, which is about guys out there fooling the system. So whenever you have an application informing of jams in the city, for example, which is a very nice idea, let's make an app for the mobile phone to tell all of us that a jam is happening in this road. Well, most people will use this app in a good manner. But for sure, there will be somebody just for showing the others that will go there and provoke an artificial jam without it existing, actually. So we have tools for this. We have algorithms for privacy. We have algorithms for anonymity. We have algorithms for reputation of people. And all these parts are also parts of the algorithms we are running and layers between the data and between the final use of the data. But of course, there's always a layer there near the user in which some guys are knowing about the information. So, well, complete removal of personal information might be impossible. Google right now knows everything on us right here. Even if you are thinking that you already deactivated your everything in Google, it is not working like so. Even if you completely turn off your phone, you are being tracked. So at some point we need to yield. We don't want. And then we will find something in the middle. And then there are some countries forcing, because it's not so easy. Some countries are putting money in hospitals and are putting money on some clinics helping the national system. They are putting money, they want data. And some countries want this data public. So imagine having your bones cracked at some moment, put on the internet. Yeah, Professor Alba broke a bone there last year. Not a good idea. So it's complex because it's the government asking for this to happen. So it's a complex trade-off between privacy and living with other people in a community. We have the community contract, the cultural contract if you want, and we are living here, we accept the rules. And at some point you are not an individual, you are part of the congregation. And at some other point you are alone, and you need to respect, you want others to respect your privacy and rights. So it's a trade-off, and that's why trials and judges exist today. But be sure that people working here are thinking and taking care of this as much as they can. Thank you.
Okay. Another question there.
Jean-Paul from Cape Town. If you're a new city trying to embark on a project like this, why would you involve your local academic community, your your computer scientists from the local university instead of engaging a company like IBM, which has got a track record. They charge a lot of money, but your local academics, they're cheaper, but they often deliver solutions that work in theory, not in practice. They don't give you the holistic picture. So who should they engage? What's the argument for engaging local academics rather than a company like IBM who sells theoretically big smart cities?
Yeah, sure. Thank you. Thank you for this question. Of course, the multidisciplinary nature of this domain is very evident. So every time you're working, you don't only have academics. You also have people from social sciences, from physics, and politicians, and everyone is there in the table. But you know, it's in this case, I'm presenting computer scientists because we are a little bit linked to this conference. Okay, but of course you can have them. If you want only to involve computer scientists there, it could be a little bit difficult because there are laws, there are psychology, there are many things that people are not taking, not just not knowing, not even taking into account every single day. So it's very difficult to have a good team having the precise equilibrium and balance between the different needed skills for making a final application. Many applications are failing because they are very good, but they fail in reaching the final users because they never made an analysis of the users themselves. And users are, citizens are the target. So that's very important, very difficult. This was a little bit more technical today, but of course when you try to move your ideas through the value chains from the abstract to the final impact in the city, you need lots of people coming from different domains. And it's a very exciting domain because you will learn lots of things from humanities and the digital humanities working out there, and also not only computer scientists, many other engineers and people not being engineers there. I'm not sure if it is your question, and I'm answering your question. It's fuzzy. It's something fuzzy. We cannot measure that, so we all have opinions, and every opinion is good.